This is Nasir Gazdar. Today we are talking about running out of water, and our theme will be sustainability of water resources in Pakistan. Now we understand that the global warming is happening, and that is due to climate change. And as we understand, climate change is all about water. And Pakistan is a country that has a water stress region, and its per capita availability of water is decreasing day by day. And importance of water in our lives is apparent uh, in our ecosystem, in our food production, and in our sustainability. So we will go and understand that what is water. Water is crucial for achieving all the four official goals of the United Nations Climate Change Conference, um, COP26, which aims for the zero emissions of carbon by 2050. Without water, there would be no life on the earth. Securing sufficient access to good quality fresh water has long been a challenge for the people in the Indus plains since antiquity. Now the climate change is exacerbating its impacts with disastrous consequences on surface and groundwaters and on the sustainability in Pakistan. Okay. So fresh water is a very tiny fraction of the Earth's available water. There is only 1%. And so this precious resource is impacted through the water cycle by the climate change. And so most of this thing in a region which is a semi-arid, subtropical, subtemperate is on the hydrological cycle. And of course, the global data is showing that the world is already locked into about 1.5 degree centigrade warming. So what is the present state of Pakistan water crisis? It's a national security issue. Water availability has been a national security issue since 1945, uh, when India stopped the waters of the eastern rivers flowing into Pakistan. Um, Way back in 1960, India and Pakistan signed a treaty to have the trans-boundary sharing under the auspices of World Bank. However, the treaty didn't realize that the global warming will happen, and it was not designed to deal with the climate change. Now, state of crisis in the water resources uh, is very complex. Under the spell of climate change, people, land, soil, and water are suffering. And the climate change is something that is urgent and growing threat to the national security. It contributes to increase natural disasters such as floods, water scarcity, and conflicts over basic resources like food and water. The tipping point in climate water driven impact is on downward trend from mountain to the sea. What is required is the better understanding and forecasting the weather and climate and taking a good inventory of the water resources in Pakistan. So water stress is a major threat to the health, education, and opportunity and livelihood. And the awareness of consequences is vital for public for taking adaptation, mitigation, resilience, and sustainability. And this infograph shows that the awareness is very, very low. Only 4% of the people surveyed are aware of the climate change and water crisis. So we will go back to the hydrological cycle or water cycle. So surface water evaporates from the ocean, lakes and rivers by energy of the sun. Then it is recycled. It comes back to the land as a runoff, and some of it goes into the groundwater. So Pakistan has both surface waters and groundwater that sustain the 220 million peoples in the Pakistan. Okay. So this pictorial shows the water movement through atmosphere, hydrosphere, and land uh, through this water cycle that has been on our Earth for past 1 billion years. Now, this, we have mentioned, the tipping point for substantial changes in the water cycle is in a flux. So climate change is tied with the hydrological cycle. And so human exposure could be due to the regional weather changes, heat wave, extreme weather, temperature, precipitation, and sea level rise. And then we have other associated problems in the ecosystem and microbial regime. And there are other modulating influences from health. These are listed in the column number 4. And what we believe that the shrinking water resources cause scarcity, and they have a effect that kind of makes the development kind of on a standstill. So impacts of water scarcity and poor water quality are seen across the Pakistan as they have limited food security, economic growth, public health and quality of life, and waterborne diseases, and they contribute to poverty and gender inequality. And there has been displacement of rural communities to the cities, and they increase the environmental degradation of soils, land and ecosystem. Now this is something in the northern region of Pakistan, in Karakoram and Himalayan region. That is the watershed for for the rivers of Pakistan. This is the Hunza Valley, where the Hunza River is getting its snow melt waters, and then it drains into the Indus River and Indus River goes all the way to the Arabian Sea. Now this is a chart. This is a graph that is showing the increase in population versus the per capita availability of uh, fresh water. It is estimated that by 2050, per capita availability will go down to less than 50 cubic meter per capita. Now, as we are seeing the global warming, and it's kind of a little warning, it has fueled heat and the droughts and flooding. And so all of these have a domino effect on the productivity of the land and the ecosystem. So what is the future look? Future look is not so positive. It is something that we all have to look into and take the precaution and planning and monitoring, so that the sustainability can go on. So what is we believe that the Pakistan will be facing far-reaching impacts on agriculture and food security, as well as on public health and hygiene, and it requires presently urgent and long-term intervention. And this the Worldometer has said that Pakistan has the world's 5th highest rate of water use. And so all of these increases in population, in global warming, water wastage, and inefficient system of agriculture has remained some of the prime causes behind ineffective use of water and its shortages. Now, the water cycle and the pattern in South Asia is governed by the monsoon. So monsoon is critical to sustaining the huge population, and global warming can potentially cause this monsoon patterns to change. So there is the winter monsoon and the summer monsoon, and they bring about the rain to India and Pakistan. The monsoon is likely to become more erratic as warming onsets. So here, we have to look into the global climate change models. So these models say that Pakistan will have more surface temperatures, heat waves, and the quality and the quantity of the precipitation will vary in time, form, and intensity. Increased evaporation rate, a higher proportion of precipitation received as rain rather than snow, earlier and shorter runoff season, increased water temperatures and decreased water quality in mountainous watershed, glacial lake outbursts causing flooding, and seawater inundation in coastal area is forthcoming. So this is the global climate change indicator, 1 degree Celsius increase in the Earth's atmosphere as of 2017. There is a 20 centimeter increase of sea level since 1880. And the United Nations wants to limit by 2050 warming to 1.5 degrees centigrade and to cut the global net carbon dioxide emissions by 45%. And the aim is to reach zero emissions around 2050. Now, climate plans require a lot of data monitoring and financial money to pursue. And so these sustainable development goals set up by the United Nations is this, that around US $26 trillion are needed for bold climate action and economic benefits. And these must be committed by 2030. Now we go to the ground level, and here we have a look at the surface water resources of Pakistan. So these blue colored are the rivers that drain from the mountain to the sea, from Karakoram, Hindu Kush, Himalayan mountains through this region of India, Pakistan, and Kashmir, and they drain into the Arabian Ocean. Now, this is a schematic diagram of the water budget of Indus Basin system in Pakistan. So total annual river flow, surface flow is around 140 million acre feet, and about 103 million acre feet are diverted through one of the largest canal network for irrigation agriculture. And along with this, the surface water, groundwater is also used. But here we can see that a lot of the water is lost in the water courses and evaporation. And rainfall contributions are limited only to 13 million acre feet. This is the typical picture in the semi-arid regions of Indus Basin. and almost 16 million hectares are, cultivated. Uh, some of the land is cultivated twice a year, in Kharif and Rabi crops. Uh, Now, these are some of the parameters of the Indus River Basin network, both in India and Pakistan. And so, of course, we can see the glaciated area, which are 2.2%, are shrinking. If the glaciers are gone, then the net flow, the net downstream flow will be limited. And so groundwater has been used for centuries. Presently, these centrifugal pumps uh, or electric driven pumps are used to pump out the water from the Indus Basin aquifer. There are about 1 million tube wells. Mostly these are in the central in this plain, because the groundwater there is of good fresh water quality. Lower Indus Basin does not have any uh, good quality. It has a marginal quality of groundwater. And through geospatial survey, NASA has found that the groundwater aquifer is, charged to a very small degree in this basin. And this is also due to the climate change and, global warming. So this is one example of the tube well and a farmland that has been abandoned. So this thing is kind of very disastrous for the farmers. The groundwater has been not recharged, and the water table has dropped almost 200 meters below the soil. And so water wells are being, some of these are being, rehabilitated. Now we will look at the traditional water management practices in Pakistan. And usually the surface water or groundwater is used by flooding the fields. And there is a system called Varabandi. So the farmer has a tendency, whenever he receives the water, he has to apply just like a flood to his field, because he never knows when his, this is turn of getting the water will come. So of course, farming is a very risky business in Pakistan. And so along with extreme weather and heat waves, the livestock and crops are being affected more than ever than before. And also this one is being also damaged by the clear cutting, deforestation, urbanization, an increase in water pollution. So this thing that the climate change is affecting both the quality and quantity of the water from the mountain to the sea. And particularly in coastal area, the degradation of the water and the land is, quite clear. So we will go and look at some of the, the ground level. So this is a typical scene in summer. So of course, due to the heat, the soil moisture is gone, and the wind, the soil will erode. So here the wind is blowing up the soil, and this soil erosion will eventually cause desertification if there is not enough water is available to soil and the ground. And so this is the great risk in Indus Basin, that the lack of water will damage crops, soil, land, and livelihood of the people. And it was reported that average annual loss of $16 billion happened due to the natural disasters in Indus Basin. So here we see some catastrophic flooding happening inland because there is more runoff, then water is not being recharged. So here a water well is now in a waterlogged area instead of the land, and then this is the misery of the people to wait for this kind of water that seems to be more polluted than being a good quality water. Uh, this is the map of 2010 floods, that 1/5 of the total land area was under water, and it was draining very slowly, like a slow withdrawal of a tsunami. And so 11 million people were left homeless in 2010 of floods. There were many causes, but when it rained, it poured, and the water could not be drained in all of the provinces in Pakistan, and it caused a lot of misery in 2010 and in the following year too. Along with this, there is a plague of saline groundwater, saline soil, and saline soil affected land. So here we can see the extent of these lands that have been abundant or they have very low productivity. So this is another environmental disaster because uh, of the global warming and also mismanagement of irrigation water. And we have pollutants from mountain to the sea, and arsenic is natural water, is a problem in both the shallow groundwater and the deep groundwater, and even in the surface water. So these are some of the location where arsenic has been found in appreciable quantities. Uh, Along with the lack of water, there is this loss of biodiversity in the wetlands and the inland lakes. Here is an example of the loss of habitat of blind dolphin that is found in Indus and in some of the lakes. So this is another challenge of ecosystem restoration that requires a lot of money to rehabilitate the wetlands and the ecosystem. So of course, the geologists, hydrologists, and all of people in agriculture have developed this kind of dynamic water resources assessment tool. This has been from the Department of Environment of Korea. It's called DWAT, and this allows the kind of figuring out, assessing the sources, quantity, extent, dependability, quality, and other alternatives. So here is a schematic of this this concept. The thing is that the water stewardship should be from mountain to the sea. In a holistic environment, for environmental stewardship is about taking care of something that we do not own. Good water stewards recognize the need for collective response to the complex challenges facing the water resources communities rely on. So we will look at this dwarf system, and this aims to secure and use water resources in a rational, conjunctive way, whether these are for the waterways, storage, or through the infiltration to the groundwater, dam water, and river water. So integration, monitoring of all these, water resources should be in place. And this is implemented through management using geospatial tools, uh, satellites, drone, and in place stream gauges, and many other things. Okay, and so this action plan aims to increase water use efficiency and ensure fresh water supply. And so we will now go and look at the goal target for this region of Pakistan. The time to act is now. This window of opportunity to make the adaptation, mitigation, and use innovative water saving devices or technology both at local, region, and regional level. And this main thing is that the technical weather forecasting and reservoir water holding capacities should take the account into the finer details of the forced by the terrain and micro scale effects, including slope, winds, and sheltering with geospatial tools. So the way the water resources are used, agricultural system is sustained, the way food is grown, changes that ultimately could save trillions of rupees and future generation may be sustained. So as we go in beyond 2022, here are some of the examples that the adaptation at local level should get started. And these some examples of water conservation, increasing water use efficiency, and harvesting water, how communities across the world are finding creative, appropriate solutions that enhance yield, future generation may be sustained. And these also need a lot of financial subsidies from the government, and some of these are very low tech method of saving the water. And we will look at these things in the next slide. One thing is that the flood irrigation method wastage is about 50% of the water applied from the canal. Now, if this is replaced gradually with the furrow irrigation, what it requires is a pump that will pump the water from the canal or from the groundwater, and instead of flooding, the rows in between the plants will be watered. So the roots can take it. Flood irrigation sometimes drown the roots. So this method furrow is more efficient. Of course, this is the rainmaking through the cloud seeding. This has been practiced since 1940s. And so these are something that one can use to create artificial rain in small areas and locally. And different substances are used, from dry ice to potassium chloride and sodium chloride and silver iodide or silver chloride. So these are the techniques that require the government support through the Department of Meteorology and other agencies to help the farmers during the time of low rainfall or low canal flows. This is another technique that has been used by China in Tibet Plateau. So this is a simulation that the monsoon cloud that bypass Kirthar Mountains, Suleiman Ranges, and Balochistan Plateau can be harvested by seeding from the soot from the burning any kind of waste. And so this one has helped in Tibet. it may help in this part of the southern part of the country. And now this one is another way of harvesting rainwater. You know, um, in villages and also in the urban areas. And urban areas can also, use this water for aquaculture and also for recharge of groundwater. It is estimated that 1 inch or 2.5 centimeter of rainfall on 20,000 square feet roof will, produce 1250 gallons of water. Now, this is another technique, another low-tech thing, that is the harvesting fog. So in coastal area and in mountainous area where there's a lot of fog, this could be used. And in some areas, like in Marrakesh, the fog have collected 9,500 gallons of drinking water per day in coastal arid zones. Now, solar powered wells are used even in Afghanistan for the opium and other things. So these solar wells, of course, they have zero carbon emission, and that way, the climate change, parameter can be looked over. So this is a way Pakistan has a great, solar radiation potential to harvest through photovoltaic cells. The electricity to pump any centrifugal pump, and and store the electricity, and also to have the water stored in overhead tanks. This is a local area in Tharparkar and Thar Desert, where 14,000 of these green water wheels have been provided to the villagers who have been facing water scarcity. And so this way also, this is a gender inequality thing, that most of the women who go to fetch the water, they suffer a lot of problems bringing the water to their homes and to water for the livestock. So in summary, the climate change is intervened with the hydrological cycle, water resources, and biodiversity crisis. The epicenter of this water crisis is not in Pakistan. It is in the watershed in Karakoram and Himalayas, far away from Pakistan. But also the ground level, mismanagement contributes to the water scarcity. And this is the thing that the federal government should set up a public portal for information on climate water nexus for public and for researchers, resource manager, educators, students, and stakeholders, so that both traditional historical knowledge and technology data could be used uh, uh, for analysis and making the future prediction. So this will allow all of the stakeholders to focus more time on their analysis and less on data collection and processing. So we scientists spend a lot more time on data collection and processing. The analysis is something, and in this one, all of the stakeholders should cooperate and bring about this sustainability thing to the water resources management in an integrated way. So of course it requires a lot of commitment, financial commitment to rehabilitate canal infrastructure, water courses, and tube wells, and giving subsidies for solar power tube wells, subsidies for furrow and drip irrigation, rainwater harvesting, and for practices that can, inculcate reuse and recycle of the irrigation returned water for groundwater recharge and, for other, uses. So in the end, my appeal is that all of us who are here should all come together and to work to conserve and cherish the water that flows from Himalayan, Hindu Kush, Karakoram mountains all the way 2000 kilometers to the Arabian Sea. So thank you all for your listening to me. I will appreciate your comments and critique, and thank you so much for your participation in this international conference. Thank you. Bye-bye.